Hello everyone and welcome to the public space. I'm back after 2 days of vacation and I have an amazing night of episodes for you guys tonight. We're starting with a discussion with Bill Gaede, who's interested in physics. Of course, he's been a guest on the show before. And then around 9 or 9:30 p.m. Eastern Time tonight, or maybe 8, I don't know. Whenever this show ends, we're gonna do a review of the movie Joker. An amazing movie. I've been very impressed. I just went to see it. We're gonna do that tonight. Bill, have you been watching the Joker?
No. I think I have more important things to do than watch, what is that, Batman or Superman? Or
It is in the Batman universe. All right, so let's get started. And as a reminder to our crowd, we have a new version of Entropy. So go join the new Entropy. The layout has been redesigned. It's V2.0. And that is my favorite place if you want to send questions or super chats tonight. And tonight our survey is, it's not refreshing right now, but in any case, our survey is Owen Benjamin a nut job? Because Owen Benjamin has been going around and claiming a lot of things. He is applying skepticism in the wildest way possible. In fact, denying that nukes exist, that nuclear bombs exist, as well as claiming that we haven't gone on the moon, and he seems to be charmed at the idea of the flat Earth, although I don't know that if he stands explicitly for it, but in any case, he denies that we went on the moon, talks about a conspiracy whereby we would have been made to believe that we went on the moon through Hollywood movie making, essentially. Bill Gaede, where do we even begin on these?
Well, in fact, I covered Flatearthers about 2-3 weeks ago, and I covered it in my last show. And I think we can summarize Flat Earthers in a couple words. The first one is that they have nothing to offer, first, as far as science is concerned. In other words, they cannot explain gravity primarily and other cosmic phenomena. That's one issue. That's one side of the issue. The other side of the issue is that flat earthers are really into conspiracy theories. They're strong on that. That's what they talk about 99% of the time. Now, I've been labeled a conspiracist. I've been starting with Lincoln, James Garfield, Kennedy's, all the way to these two guys, these two bozos, Assange and Ed Snowden. Those are all government operations. So, I've got a little bit of history on conspiracies. But as far as taking that and saying that NASA never sent, anyone to the moon, for example, one issue. Another one, they say that there are no satellites. Communications are done with balloons and with underground cables. I think these people are taking it a little too far.
Absolutely. Some people were reporting on the regular chat that entropy is down. That's because Zdez has been sending you guys the wrong link. Zdez, you must refresh your entropy link. We are now on entropy 2.0. Now, you were talking about the gravity problem in the flat Earth model. Yeah. To some extent, you can take the flat Earth model as a big joke, essentially. I don't know if that's because I'm just out of the Joker movie. I see jokes everywhere, but there's a form of humor. There's a form of humor in re-questioning everything and trying to come up with alternative model. I believe that one model I've looked up for gravity in the flat Earth is that essentially we are on an accelerating plate that's going toward the heavens, and the acceleration of it is 10, whatever g is. So we are essentially in an elevator.
9.8 meters per second square. If you look at the second GIF that I sent you over there, O2, you'll see, no, the second one. That's the first one. If you look at the second one,
let's
O2.
Get to it here.
Yeah, this one. 9.8 meters per second square. They're saying that there's dark energy, dark matter or something, whatever, God pushing the Earth upwards. at an acceleration rate of 9.8 meters per second square. And one fellow pointed out, which I thought was a good criticism of this notion that these people have, it's that, assuming, it's not the apple that fell on Newton's head, but, the Earth that came up to meet the apple, that means the Earth has been accelerating at 9.8 meters per second square for the last billions and billions of years, right? And that means right now we should be traveling faster than the speed of light, because this acceleration is permanent. It's every day. And so if the Earth is being accelerated, that means, and we've been accelerating, I don't know, for at least a couple billion years, I would say, that means the Earth is now should be traveling faster than the speed of light.
Yeah, I mean, but that's a good question. In terms of the relativistic experience of the accelerationist field under gravity, how does that work? As we get closer to the speed of light, would we feel less acceleration? Is that how it works? Or would essentially is it the energy that matter, the energy invested in the acceleration for the feeling of acceleration? Or is it the absolute value of the speed difference in per acceleration term?
Well, we have to look at it as, this acceleration is happening every second, because we're talking about little g, which is here on Earth is 9.8 meters per second square. They do not recognize anything other than the Earth being flat. Everything in the universe is rotating around the Earth, essentially. The stars, the moon, the sun. So it's the Earth that's accelerating. And if that's happening every single second, right now we should by far have been exceeding the speed of light. And, I don't know if they're aware, but we cannot travel faster than the speed of light.
Very interesting.
I guess they'll deny that as well.
I was looking to lay out tonight the good arguments against the flat Earth, although it's kind of ridiculous to even engage with it, but it's good to have these arguments in pocket. So first argument, we would have accumulated so much speed that we would be traveling at the speed of light. Now, what else are the features of the flat Earth model?
Okay, look at the, now you can put 01 there, the one you put earlier, the 01 flat Earth model.
All right.
Okay, now this is essentially, in a nutshell, what they're proposing. They're saying we have a flat Earth, and on the edges, there's ice. Okay, that's the ice going around there. And the issue, I want you to focus on the sun and the moon. Now, we know for a fact that every now and then we get an eclipse, right? And we get an eclipse not only of the moon, but we get an eclipse of the sun. And so the issue is that in order to get an eclipse under this model, you would have to look at it from below upwards. That means the moon would have to get in front of the sun in one instance. And then in the other instance, the sun has to get in front of the moon, because we do have lunar eclipses. And, they haven't figured that out. You won't find a rational explanation for eclipses.
Absolutely.
And that's something verifiable. I mean, that's something, we got a little bit of experience on.
Yeah, we got direct pictures of it. I was noting that's one thing I had forgotten. In the flat Earth model, the sun and the moon are pretty much the same size because they are experienced as the same size in the sky. Another argument I've heard on that line by Owen Benjamin is he says, can you imagine that the sun is X times bigger than the moon, and yet they are the exact same size in the sky? How do we attain this through random? He's essentially invoking the fact that it's a statistical abnormality that they would happen to end up with the same size in the sky while having very, very different mass. What would you answer to this one?
Well, again, it's first very unlikely, but I mean, if you're a flat earther, I guess you can justify anything. Keep in mind that, in that model that you just showed there, Antarctica is on the edges, right? The edge of that plate, that's Antarctica, right? And it's all around the Earth. It's all made of ice. And there are two arguments there which just blow you away, and that shows you how far these people have gone. The first argument is that the oceans don't drain into space because there's a wall of ice surrounding the Earth. That's the first one. The second one is that, well, you say, well, why can't we just go down there and verify, with our own eyes, that there's this wall of ice and that the ocean stops there, right? Very simple. And they say, well, because we have all these government forces which are preventing you from reaching the edge of the Earth.
The globe cucks.
And I guess a lot of, I would assume if that's true, because that's our modern version. We have all these military guarding the Antarctica, right? Fine. How about 500 years ago? I guess the ships just fell overboard. There were no Marines there to block the, our knowledge of Antarctica.
All right. You were also bringing the definition of flat. Flat means horizontally level, even or without unevenness of surface. Having a surface.
I want you to focus on the fact that these are the definitions of ordinary speech. This is what you'll find in the regular dictionary. Okay.
Okay.
So, and the issue is that because, flat Earth, you might laugh at them, but we have the flat universers, and those are known as general relativists. They believe that the universe is flat.
Wait. The general relativists allow for curvature of the universe.
Yeah, but no, because they say locally it's flat. It's like the Earth, the same argument the flat earthers raise, in fact. They say, well, how come, all the train tracks are straight ahead and, and the roads are straight? And you say, well, if you look at the size of the Earth, you're looking at a very small piece. For that small distance, it's essentially flat. And that's what the general relativists say as far as the universe is concerned. It's such a big ball, 4-dimensional ball, that, when you look at any piece of it, it's relatively flat in comparison to the entire universe. So that's what they're referring to there. But there's a definition. You can see there, the next two, if you look at 04 and 05. 04 has the definition. This is the definition of general relativity of what flat means. And they say essentially, if you are in your room at home and you are in one corner and you go around your house, in other words, you go 90 degrees, 90 degrees, 90 degrees, and 90 degrees 4 times. That's why I got that number 4 in red there. If you go around it 4 times and you end up in your starting point, that's known as flat according to general relativity. If you do it 3 times, like if you go around the equator, take a left turn 90 degrees, go to the North Pole, take a 90 degrees, and you end up back on the equator, well, then that's known as non-flat. That's roundish. And so they're saying that essentially flat is something you cover with your feet. You prove to yourself by going around 4 times at 90 degrees and ending up where you started from. That's known as flat in general relativity. And then you have the scientific definition, which is number 7 there. If you look it up, that's the flat definition, the definition of flat of science. It's lacking thickness. That's flat. And so the question is, how flat is flat? How flat is the pancake Earth that the flat earthers propose? I mean, how thick is it? When they say flat, are they talking about a pancake or are they talking about a plane, like a square, or whatever? No thickness. How flat is flat?
Well, I guess that they would tell you it's at least as thick as required to explain that we find volcanoes, that when we drill, we do reach points of the mantle, I guess. So I guess that they would tell you that it's at least a few kilometers thick, and that we just never dug further than that.
Yeah, but see, it creates a problem because, again, the word flat comes into play here. They're known as the flat earthers, so they better define the word flat because it's part of their label. And the issue is we have, Mount Everest, which is not very flat or doesn't let the Earth be very flat. we have the Marianas, which is very deep in the Pacific Ocean, the lowest place on Earth. And so we have this distance between the highest place and the lowest place, assuming we have a flat Earth, a pancake Earth, let's call it a pancake Earth. And we have this depression, we have this high point. The question is, again, how flat is flat? They have to tell you what they mean by flat. And they don't have a definition of flat. They're not into science. They're into conspiracy theories.
All right. Other arguments that were made relate to the horizon and the whole idea that boats, the way they disappear, is not compatible with a circular view of the world. Which of course I've debunked partly here on this channel by looking at the flat salts, salt flats. I believe that's how they're called. They are extremely flat parts of the earth where salt has been accumulating from the drying of water, and it leads to seeing essentially things like a pickup truck disappear in the horizon, compatible with a curvature of the earth.
They have all these arguments about they can come up with any scenario. The main one, or one of the most important ones they come up with is that if you're on an airplane, you look at the horizon, it looks relatively flat. And again, I travel on airplanes, and you look at it and there is a slight curvature, but it's very hard to determine just by eyesight if the earth is flat from an airplane, again, because you need to have this longer view. You need to see more earth. And you can do that, from space. You can do it, like, for example, from the space station. And they do have pictures of the round earth from the space station, if there is such a thing as a space station. Of course, if they deny that, well, what is NASA supposed to do? Take each member of the Flat Earth Society out there to see it for their own self and prove to them individually that the earth is curved? Again, an airplane would have to be very, very high to really see a curvature. That's one issue. The other one is that, and airplanes is a good example, because, all these pilots, they have to use these routes every day. And for all pilots on planet Earth to believe that the earth is round, that's quite a bit of consensus there. I guess the CIA bribed a lot of people, to get this round earth theory out there,
Now, on a final point, perhaps, which is more a point that Owen Benjamin makes, because although I think he's never really endorsed flat earth theory, he endorses a bunch of points that are parallel to flat earth conspiracies. One of the points that he does make is we've made up the idea that we went on the moon. Now, you, Bill Gaede, how do you convince yourself that we went on the moon? What is the best argument to show that? I guess we should exclude from this the videos, given the potentiality that they would have been made up. What is the best argument that proves we were on the moon?
Well, let me tell you this again. I've been labeled a conspiracist because I believe in that a lot of the politics has tons of conspiracies, of false flags, etc. Right? Now, take Kennedy's assassination. How long did it last? A couple seconds. Take the towers, 9/11. How long did that last? It was quick. And compare that now against what these people are saying about NASA and programs like the Apollo program that lasted years, involved many people who control this over and over, right? And, it's very hard when you have something ongoing like that to control that, to control the information first, and second, not to be verifiable by tons of people. And that's different than, something that happened all of a sudden, assassination. You get caught off guard, you look at it, it's a few seconds, maybe you have a movie, and, that's all you got. And so that's easier to cover up. But to cover up something, an ongoing operation like the Apollo program, that's very hard to do. That's one issue. The other issue, I think, is probably more important. Again, it relates to politics. In Laika, the Russian dog went into space. When Gagarin, the first human to go into outer space, Tereshkova, the first woman to go out into space. The Russians claimed the Soviets, right? They claimed all these goals. They really beat the United States. The United States did not go in there and say, no, that's all fake. It's Soviet propaganda. And conversely, when the United States said, okay, we're going to go to the moon first, they put the Apollo program into place. And they did put a man on the moon, apparently, right? Mr. Armstrong. The Soviets did not say, oh, no, that's all propaganda. It never happened. And you would think that these enemies, because they are enemies, right? They're different mafias. One mafia is in Moscow, the other one's in Washington. These mafias, they're going to try to do anything to undermine the other side. And here they did. Neither the Americans, in fact, the Americans panicked because they said, look, the Russians are already out into space. We haven't even gone up there. And these guys have already sent a human up there. So they were worried, and that's why they put the Apollo program, in place, because they were worried about the Soviets gaining advantage in space. And so for the Americans to treat that and say, it did happen, and yeah, we take our hats out to the Soviets. They put a man into space. It would have been much easier for Washington to say, no, it never happened. It's all fake. It was done in Moscow's Hollywood, And they did. They took it seriously, and vice versa. The Soviets took, Armstrong's stepping on the moon very seriously as well.
Well, that is an argument based on absence. I mean, you could think that the Russians did not criticize, but it was for some other reason. I would say personally, the arguments that convince me is the presence of mirrors on the moon that can be that have been installed manually and that can be sent light from the Earth, as well as the China pictures of the moon site where people have been using the rover. I think they are pretty convincing that they are not natural paths that were driven into the sand.
Yeah, but Flat Earthers going to tell you that all that's done in Hollywood. It's all done with pictures. Anything related to pictures, they're going to say it's fake. And,
absolutely.
Another issue, and that's not only for Flat Earthers, because there are a lot of other people who are not Flat Earthers who don't believe that man went to the moon. And one of the arguments they raise, or the argument that I raise against them, is that, these people find all kinds of faults. The shadows are wrong. The stars are not in the background. The gravity is not proper. They get all these errors, right? And I'm saying one of the problems I've got with that is that the more errors they find, the less believable is their argument, because the directors of Hollywood could not have made so many errors. I mean, if this was done in Hollywood, the movie, the pictures, everything, if it was done in Hollywood, they wouldn't have made so many errors. It's like making a movie of the Romans and having someone with a wristwatch. The directors look for these things. They say, "Hey, did you take your wristwatch or Rolex off before we filmed?" And they wouldn't have made so many errors. And so the more errors they find of man on the moon, that something is not right, the less likely is their argument, the less believable is their argument.
All right, that's wonderful. Another argument we've not mentioned back on the flat Earth theory is the tides. The tides are very hard to explain for a flat earther without gravity and without the mass of the moon pulling this water up.
Yeah, that's true too. Newton showed that the tides were caused by the moon. And if we take that out, well, again, these people are not providing answers, alternative answers to these questions, to gravity, to the tides, to light. I mean, if they're going to be scientific about it, well, they should really give more answers than just say, well, it's all a conspiracy and they don't let us understand, they don't let us see. And, that's politics. Do science. If you want to get your flat Earth theory or hypothesis across, come up with explanations for, among other things, what you mentioned earlier, nuclear weapons. How does the sun work? Explain eclipses, explain gravity. This is what we want. But if these people are just going to say, it's all conspiracy, and they're just going to be naysayers saying, well, whatever we hear is all fake. Well, yeah, then if that's fake, what is true?
All right.
This is the issue.
Before we move on to the subject of radioactivity, we have a few questions from the crowd. Thank you so much, you guys, for using Entropy. It is the new platform, and I see that many of you have joined us there and are sending your super chats there. White Supreme Cis Male sends $20. Thank you so much. He says, Bill, what is the 2 and 3 body problem?
2 and 3 body problem is the issue that if you take the Earth, okay, and the moon, you will have an eclipse, right? The moon goes around the Earth, and we have an eclipse with respect to the sun. In other words, the moon blocks the sunlight from reaching the Earth, okay? We all know this. Okay, so what is the explanation that relativity has for this is that the sun weighs down the canvas, the space-time canvas, and the Earth weighs down the space-time canvas, and that's the reason the moon goes around. Now, what is the problem? The problem is you cannot extrapolate that scenario to Uranus. Uranus, you have this moon that goes over the poles towards the sun. And so if the sun weighs the canvas downwards, and Uranus weighs the canvas downwards, the moons of Uranus should go just like our moon. It should go around their equators. That's not the case for Uranus. It goes around the poles. And in the case of Pluto, we have the same thing. It's got its moon, Charon, and Charon forms a bullseye pattern as seen from the sun. In other words, instead of going around the equator, right, it goes around the poles, but in a bullseye pattern as seen from the sun. And again, that means that Pluto would have to push the canvas outwards. Uranus would have to push it sidewards, and the Earth would push it downwards. And so Einstein's mechanism for gravity cannot be extrapolated to 3-body system. It can only work with 2-body systems, at least in our solar system.
Very interesting. I was not aware of this. How do they explain then the Uranus vertical positioning of the satellite?
They let it die by pocket veto. They simply don't deal with these issues.
Really?
Nobody
There's no explanation for why it is that way.
No, absolutely not. Of course not. That's why they cannot have this to a 3. They cannot extrapolate the 2-body system. They can explain easy. We all can imagine a bowling ball weighing down the canvas and a little marble going around. We can all imagine that. Now do it with 3. Do it with 3 now, and you won't be able to do it. It's simply impossible. Especially if you look at our solar system, it doesn't work that way.
Well, that is quite shocking. It's mind-bending to try to think of the canvas being space bent, the space-time being bent in 3 dimensions. Very hard to conceptualize without imagining it back to a 2D world. But I didn't know that there was no explanation. It's somewhat worrying, but is there anything that forces these orbital paths to be aligned, really, to be flat? In other words, aren't you kind of a flat earther in expecting relativity to force? I'm just kidding here, but you're a flat orbiter. You're being a flat orbiter. And by the way, people on the chat are requesting that you close your Discord because I think we're hearing some of the noises. Hopefully you get a chance to.
If I can, give me 1 second so that I can get rid of my Discord here.
All right, no problem. While you do that, I'll read some other questions. Yeah. Kjell Erling says, host a debate between Vegan Gaines versus Edward Dutton. I'm up for it, but Edward Dutton has his own channel. I suspect that if they wanted to host it, they could do it on his channel. That being said, if they need a third-party moderator, I'm not close to the idea. UXG Freestyle says, "Oh look, an old drug addict and a Cuban midget." You're hurting my feelings. He's calling me a drug addict. And you... That is very evil. Oh my god. All right. And Pregnant Trout says, thumbs up, thumbs up. The Pregnant Trout is back. Did you follow this whole Kraut escapade that I had where I was arguing with a YouTuber named Kraut who was making scientific videos that were used to justify leftist view, and I was debunking them. And at some point he claimed that trouts were pregnant, that the pregnancy, the length of the pregnancy of a trout was very short, and I was laughing my ass off because there's no pregnancy in trouts.
No, I don't deal with those issues.
Okay, no, you don't. It's like the Joker movie. It's not your thing.
Yeah.
Pineapple Platypotamus says, pendulum exhibits in museums prove the Earth is round. Really? Can you prove that the Earth is round using pendulums?
Well, it's related to gravity. And again, if you have a different version of gravity, which in this case is that they say the Earth is accelerating upwards with quotations, whatever upwards means in space. Well, yeah, I mean, I guess you can justify almost anything. Again, a flat earther is a person who is going to find all kinds of excuses, and all the excuses will be related to conspiracy theories that, the information is being kept away from us. So, this gentleman is correct. If you look at Foucault's pendulum, which is in France there, it moves, and it moves thanks to the fact that the Earth is round, and the center of gravity is in the center of the ball, so to speak, okay? If we have a flat Earth, well, I don't know how you would explain this pendulum, even if there's an acceleration of the Earth upwards, again, whatever upwards means. I'm not sure you could explain the pendulum there.
Very interesting.
It's up to them to come up with an explanation for Foucault's pendulum, for example.
How does that look, a Foucault pendulum? Let me Google it. So it's a kind of circle like that. How does that work?
Yeah. Well, again, it's the movement of this pendulum with respect to gravity. It's under the rope model. I can explain it to you very easily. Every atom of that ball is connected to every atom on Earth.
So I'm trying to get to C1 in the works operating. I don't see much move here.
It decreases because of the friction of the air, and you make the system bigger, and there's still friction of the air.
All right, so essentially they claim that this was sufficient to prove globe Earth. Let's get into the question of radioactivity, because one other thing that Owen Benjamin denies is radioactivity. Doesn't deny, but he denies that uranium can be used to build nuclear bombs. So how should we conceive of radioactivity? How does that work?
Well, you have the quantum version, and I can only give you my alternative rope version. They're very different. The quantum version is that you have a nucleus, and some elements like uranium are spontaneously get rid of alpha and beta particles. Alpha particles, think of it as simply a helium atom, which means that it's got 2 protons, 2 neutrons, right? And so it just expels, uranium atom will expel or get rid of what is known as an alpha particle, a helium atom. And then you have the beta decay, which is, that gets rid of electrons. A neutron essentially has the mass of a proton and an electron put together. And essentially what you're doing is getting rid of the electron from the nucleus. That's the theory. The problem I've got with the quantum version, with the quantum explanation mechanism, is that to begin with, it's what I had with Peter when we had our little debate there, and that's that, you know, they cannot draw for me an atom, any atom, even the simplest, the hydrogen atom. Why? Because they can draw a proton, which is a particle made of 3 particles, allegedly 3 quarks, and they can draw an electron. What they cannot draw or tell me is what keeps that electron bead bound to the nucleus. That's what I want to know. And they can't do that. They never have in the last 100 years. And so before we can get an expulsion of a helium atom, of an alpha particle, they have to show me what the uranium atom looks like. And they can't do that. On the other hand, on the rope model, if you look at...
well, before we get into the rope model, I wanted to understand, do we have a mechanistic explanation of why these atoms release these particles? Is it just that the force of the nucleus becomes too unstable and unsustainable when there's too many neutrons, too many protons? How does that work?
Well, under quantum, it's just done by hand waving. It's done with a magic wand. Under the rope model, you know, I do explain it very easily. You know, if you have, for example, take the hydrogen atom, right? If you take deuterium, it's got a neutron in the nucleus. So you have a proton, a neutron, and an electron on the outside, supposedly, right? And now you go into tritium, and now you have 2 neutrons. Well, what happens under the rope model? It's very easy because it's what you're doing is you're compressing more matter into it's like, think of a balloon, and you're putting 3 balloons inside a balloon. Well, if you put only 1 balloon in there, well, it can, you know, nested balloons, it can handle it. You put 2 balloons, it's going to be strained. If you put 3 balloons, it's going to be radioactive. It's going to be unstable. But under the quantum version, there is no explanation. It just is. They just say tritium is radioactive because God made it that way.
So to be clear,
and the problem we have, JF, is that under the quantum model, you say, what's the purpose of neutrons? Why did God create neutrons? And they say, oh, very simple. The neutron is used there to keep protons apart, you know, because protons are all positive. They would push each other away. And so if we put a neutron in between, well, it kind of acts as a referee, right? But in the case of hydrogen, there's only 1 proton. In the case of deuterium, there is 1 proton and 1 neutron, right? And if the purpose of neutrons is to keep protons apart, why did God put, you know, a neutron inside deuterium? Why did it put 2 inside tritium? So there's no reason. They just say it is. It is. So.
Well, the thing is, I don't think that it is the claim of physicists that neutrons have a purpose. It's just that the forms that we see in the universe are only those that are stable. And of course, a proton-only nucleus with many protons would be unstable. That's why we see nucleus that have neutrons.
Why would it be unstable? I mean, again, there's no explanation. They just say it is, but they don't tell you what physically causes an atom, a heavy atom like uranium 92, you know, protons, electrons. Why would it be unstable? See,
because of the little pluses. There's little pluses that are pushing each other like this.
There's what?
Little pluses. The plus are expelling the plus, and the negatives are expelling the negatives. And the plus and the negative, they pull on each other.
You know about p orbitals, right? You've heard there's an s orbital that covers an atom, which is a round one, and then you have the figure 8, which is the p orbitals. Okay. And the issue, it shows you what the problem is in quantum mechanics. You have a p orbital, which goes right through the center or very close to the center of, you know, to the nucleus. And you say, well, hold it. The electron is negative, right? And we have a positive nucleus. Why does the electron get so close and not get sucked in like a magnet? You know, here it goes right through. In fact, in many cases, you'll see they illustrated the electron going right through the center of the atom and out the other end. Others simply say, well, it goes very close. Either case, why doesn't the nucleus just swallow that electron? What keeps the electron bound to the atom? What prevents the electron from being sucked into the nucleus if the nucleus is positive and the electron is negative? And they have no explanation. They just say it is so. There is no explanation.
Yeah, I mean, it's a good thing to raise. I don't know that I had ever thought about conceptualizing it, but couldn't we see the electron as a never attempting shoot that cannot be as precise as to collide into the nucleus? And so because of, let's say that the electron is subject to Heisenberg uncertainty principle in its collision, and it never quite collide.
Well, it does collide because, see, a neutron expels during beta decay. A neutron supposedly expels an electron because that electron somehow got stuck to the proton to neutralize the charges.
They trapped electrons. I didn't know that.
Yeah, so I mean...
But how do you approach neutrons in the rope model? Because I was looking at this here. You have an atom model where you have the threads. I believe that the threads represent negative and positive electricity forces.
No, there's no negative or positive. All we have is ropes. Those are ropes, and what you have is the thread is only in the blue area, in the center of the circle. Okay, so the threads, one thread goes around and forms that red circle that forms the boundary, or what I call the electron shell. And then the proton, which is the center, is made of threads from every atom in the universe. So the rope stops at the electron shell, at the circle. Mm-hmm. Okay, you can see those are ropes, and then what continues are threads.
Now, where are the neutrons in there?
Well, the neutron. Unfortunately, you didn't ask that question before the show. I would have sent you a picture of the neutron, but I'll see if I can explain it and you'll probably understand it. Just think of because it's neutral. It has no such thing as charge. Okay. Remember, charge in our model is that the atom expands and contracts doing quantum jump. Okay. So what happens at the place where the rope forks out and forms the atom? There's a little friction there. You know, it unwinds and winds constantly. And if you add all those, if you aggregate all those areas around an atom, that's what we call charge. Okay, each one of those points is a charge. The neutron doesn't have charge. So the question is, how do we do neutron? Well, the neutron doesn't have the rope does not fork out. That's what it is. The ropes continue straight to the other side in every direction. And so if the proton is a convergence of electric threads or just threads, a neutron is a convergence of ropes. All the ropes just continue. There is no circle as you see there. Okay?
So the threads remain together. And so that's why we don't distinguish an electric charge. We have both red and blue components all at the same place.
Yeah, in other words, the ropes continue straight. It's a convergence of ropes, and that's why it doesn't have charge, because there is no quantum jump in a neutron.
Wow.
I should have sent you the picture. Maybe I'll send you the picture afterwards. At least you'll understand it.
Fascinating.
Our audience is deprived of that picture.
All right. It was really in my mind since the question. He says, is the rope/fabric you describe existing within the Calabi-Yau space? I don't know if you know that term.
Yeah, the Calabi-Yau space. Well, again, these people are obsessed with mathematics, and we do physics. Physics does not care about all these equations. We're just interested in understanding mechanisms. Okay, so we do not like to step over the boundary into mathematics because again, that's a place that does not correspond to physics any more than physics corresponds to equations. They can do their equations over there, but when they come to the physical interpretations, that's where we have a clash with the mathematicians, because these people are trying to interpret what they see in the lab, or they're interpreting their equations, and they give you a bogus explanation for how the universe works. They tell you a particle can be at two places at once. What do you mean? Or they'll give you the uncertainty principle. They'll say, the electron can be anywhere. We can't figure out the position and the motion, the momentum of a particle. And they go through all this stuff that has nothing to do with physics, but they give you that physical interpretation based on what they, calculated or what they think they observed in the lab. But it's very easy. If you go to the standard model of quantum mechanics, if you look it up on Wikipedia, you'll find that they don't have a picture of any of the particles. They've never seen a particle. And they never will, because there are no such things as particles. So if you say, well, what does a Higgs look like? What does an electron look like? They don't know. They don't even know what an atom looks like. They say they took pictures that they filmed, they interviewed them personally, and no one can draw an atom for you because they don't know what an atom looks like. And if they did draw an atom, all they would have to explain is how that little bead stays faithful to the nucleus before it ionizes or goes into electricity. And that's what they can't do. They never have explained what keeps the electron bound to the proton.
All right, I was Googling what is the Calabi-Yau space. I don't know about this at all. Calabi-Yau manifold. Apparently, that's a 2D slice of a 6D manifold. Too complex for me, above my pay grade. Pineapple Platypotamus says, does your guest recommend Richard Feynman videos?
Yeah, I recommend the magnetic one, especially when they ask him to explain how a magnet works, and Rich, is not able to do so. And Rich also has a couple other things which I like, which is he made statements. He said, no one understands quantum mechanics. And people don't listen to what he said. Because you talk to a lot of people. In fact, I got a Quora article in which someone criticized and said, well, yeah, they do understand. See, we have all this technology. The computer you're using is thanks to quantum mechanics. And, they go through all this stuff. They don't realize that, these people are telling them in their faces that they don't understand quantum mechanics. And I'm not only talking about Rich. I'm talking about people like Leo Susskind. He's from Stanford University. He tells them, we don't understand quantum mechanics. And these people are listening to that. They say, sure, we know you understand it, because otherwise we wouldn't have the technology. And that's all they can say. GPS proves relativity, and computers prove quantum mechanics. That's all they understand. They don't realize that technology has nothing to do with a physical interpretation.
Leo Susskind is very solid. Fascinating. I've seen a speech of him where he was talking about our universe, our observable universe, being only one branch of potentially a Big Bang that would have been much bigger, that would have resulted in many such branches. Do you believe in such a thing as the fact that our observable universe is essentially isolated as a consequence of the speed limit of light, the fact that we're in an isolated bubble and that there is other observable universes out there?
Yeah, of course. I think the universe is much greater than what we can see. So they talk about two universes. One is the observable universe, and then all the others are supposedly, parallel universes, even though they all came out of the Big Bang. So, whatever they mean by that. Again, they never pinpoint the exact thing, because they consider all that philosophy. They say, no, we dismiss that as philosophy. I call that physics. Physics is trying to understand how this universe works. And if it's like they say that we came out of an explosion, right, that occurred 13.8 billion years ago, then the observable universe is what we can see, and then what's out there? What do we call the rest of it? And they say, well, that's not part of our universe because it doesn't matter anyways, because we can't see it, we can't test it, we can't do anything with it, so we'll just consider it as if it's inexistent. Yeah, and that's not true. And if you try to make sense of it, they say you're doing philosophy.
Yeah, it's hard because science is defined around our capacity to observe, but yet it's almost impossible, and I would argue impossible, that it just so happens that the universe we see is all there is. And so personally, I also think the Big Bang must have led to much bigger than what we see, but we'll never know, probably. Alexandru Kohaniuk,
well, we will know.
How will we know? How will we know the size of the universe outside of the observable bound?
No, I'll tell you that we will know that there was no Big Bang. We can know that for sure.
How will we know
that? Perfectly easily. Take nothing and try to tell me how you create something. Even if you're God, right? I'll give you all the power, all the superpowers you want. And you need to create something from nothing. Show me the mechanism.
Well, that's an attack of the Lawrence Krauss position and framing, but you could imagine easily a Big Bang not starting from nothing, starting from something.
What? Starting from something. Well, we already had something, then we can't create something from.
You don't deny
something from something, but not something from nothing.
You don't deny space expansion.
Yes, I do, of course.
You do?
There's no such thing as space expansion because space is nothing, and nothing cannot expand. Only things can expand.
But the change of color, the frequencies that as we look further, they get more red or more blue, depending on the distance and depending on how much the light that's coming to us has been made to be more and more red. How do you explain this one?
Yeah, the Doppler shift.
Yeah, Doppler
Very
shift.
easy. Okay, here's a rope.
Okay.
My famous rope, okay? Okay, now you're looking at it head on, right? Let's see if I can do that. Like that, okay?
Uh-huh.
Okay. There. Okay?
Okay.
So imagine now two galaxies, right? And they're far apart, okay?
Yeah.
The farther they're apart, the rope is going to the links are going to become longer.
Okay, because there's kind of a force.
No. Listen, if you tie a rope, right? Your grandmother's rope between a clothesline, okay? If you go farther away from the edges, like towards the center, the links will become a little longer. Okay. And that's here on Earth. Imagine gazillions of miles now out there in space. So for sure, the farther a galaxy is from us, the redder it better be. On the other hand, the blue shifted galaxies, which are in our local group, like Andromeda, is coming towards us, according to the official word. Why? Because it's blue shifted. Why? Because it's close by. 2 million miles away. What is it? 2.2, I think it is.
Okay.
It's close by.
Okay.
Whereas the other galaxies are very far away, and the ropes, of course, if I were to follow the rope from an atom here all the way to that galaxy over there, it should little by little the links should become longer. Longer links. Red. Very simple.
So you think it's
explain with the rope model. We don't need speed for this.
Essentially, the Doppler shift model and the traditional model would tell us that it's absolute random, the fact that this galaxy is headed toward us and that it's blue shifted. You say it's not random, it's related to the fact that it's close to us?
Well, I think there's going to be some gravity at this level, at the galactic level. The local group has like 56 galaxies that they found, and all these galaxies are bound to each other. Again, I'm saying they're physically connected. All the atoms over there are connected to us. So that's the gravity. And, when you have this massive galaxy, I think that at that level, they pull each other in a gravitational attraction. Okay, so there is some drifting towards us. So it's very likely that Andromeda is moving towards us. What I'm saying is we have to distinguish what relativity says, that they claim that the universe is blowing apart, and that's how they came up with Big Bang. I'm saying that's not true. The farther a galaxy is from the Earth, the redder it should be, because the ropes are, the links on the ropes should be longer. And a longer link means that it's red.
Uncle JZ says, what force is pulling the links farther apart?
Just drifting. It's just drift. For example, the Harvard Tower experiment, they measured a change in frequency as the beam went from the bottom of the tower to the top of the tower. So they were able to measure that change in frequency, and they were astounded by that. But it's not astounding, because if you take a rope and you take it from source and outwards out into space, that link, without any movement, just the link should become longer the farther you get away from Earth.
All right, very interesting. We did have some comments to do on radioactivity. I'm getting some echo from you. I don't know if your speaker is too strong. Perhaps you can...
Oh, is it? Let me lower it a little bit.
All right, perfect. Torrin McCabe, before we get to our final comments on radioactivity, says, if by observing a photon we can alter its actions within space and time, could we communicate by altering photons in Morse code, essentially plucking the ropes he describes? Okay, that was one question. So let's start with this one. Well, I think altering photons is essentially what we do with fiber optics, right?
Well, again, we have to see. We have to find out what a photon is. Under the rope model, it's just a link of the rope. This is a photon here. That's a photon.
Mm-hmm.
And these people say, well, it's zero mass, zero volume. So what are we talking about? We have nothing. A photon is nothing. It has no mass, no volume, no anything. But they use it. They represent it with a little ball. They say, well, it's a ball. And when they need the frequency and the wavelength, then they put James Maxwell's famous transverse wave, and that's not an object either. It's just a bunch of vectors. And so we have either vectors or a little ball. And when you say, well, I want to know the physical interpretation, they say, well, that's philosophy. It's like you never get a physical interpretation from quantum, not one that you can rationalize. That's why they say, nobody understands quantum mechanics, because they never were able to rationalize it.
All right, Dieter Johnson on the regular chat accusing me of having zero per Nordic genetics. Well, fuck you, Dieter. Torrin McCabe says, why does Bill assume that atoms look like or act like physical objects? His assumptions are based on his eyes and hands, which are not adapted to view atoms or physically interact with them.
Well, we start with a definition of what an object is, and we say that physics cannot be done without objects. If there's absolutely nothing in the universe, just empty space, just vacuum, there's nothing going on. So physics starts at the principle, what I call the golden principle. You can't do physics without an object. So anyone who does physics without objects is doing religion. He's doing spiritualism. He's essentially introducing spirits in that same space and say, I'm going to move concepts around because, I can't see it. I can't touch it. I can't touch light. I can't see light, the mediator of light. I can't see gravity. I can't see the mediator or touch it. So I'll assume it's a spirit. They'll just do, and they work with mass, they work with energy, with all these concepts, but you never see the meat. You never see an object, not in mathematical physics. And so, yeah, I do assume that atoms are things. A thing is that which has shape. And, I can draw my atom. Quantum can't draw its atom.
All right. Alexander Kohaniak sends $10. He says, Uranus is tilted orthogonally related to the sun, as well, not only its satellite. Could it be possible that this is only a temporary situation caused by a cosmic event?
Yeah, I mean, my point was on Uranus, my point was that if you can't extrapolate the three-body system that we have, like Earth, Moon, and Sun, you can't extrapolate that to Uranus and what is it, Oberon, that goes around the poles, or to Pluto and Charon. You can't extrapolate it, because if the sun weighs downwards, and we're going to have that, the equator of the sun, right? It's weighing down in that direction, south, considering the equator. If you look at Pluto, you have this bullseye pattern, and that means Pluto would have to push outwards for Charon to go around in the way it does. And that's the problem. The problem is the three-body system. Now, Uranus, yeah, of course, it's possible that something happened, like Venus. Also, Venus rotates very slowly and in the opposite direction. So something happened in all these cases. And by the way, my theory on that, which is good to know because it is very different. The Earth and all the rocky planets, they were stars.
The Earth.
In other words, the only way
you believe that the Earth was a star before?
All round differentiated rocky planets, star, moons, etc., were stars. The only way you can get roundness and differentiation is in a mechanism such as what's happening in the sun, inside the sun right now. You have to have compression of the atoms, starting from the outside inwards. You got to have hydrogen being pushed in, constantly being merged through fusion. And that's how you create heavy elements such as iron in the center, followed by silicon, less dense, less massive atoms, followed by the gases. And that's, if you look at Mars, if you look at Venus, if you look at the Earth, they're all made like that. They're all made with heavy elements in the center, followed by lighter elements, and eventually, in the case of Mars and Venus, by CO2. That's the construction of a star. Only Venus was a star, Mars was a star, and they've been around billions and billions of years, way beyond the Big Bang.
You cannot imagine a mechanism that only relies on gravity and non-fusioned elements that would explain the roundness of the Earth.
Absolutely not. But I would love for someone to rationalize it for me otherwise. I think that the Earth used to be a star. It was compressed, and that's why it's differentiated, and that's why it's round, almost perfectly round. That's a star. That's the definition of a star.
Well, I mean, it's easy to imagine, but just imagine a planet that is on an axis like this, and there's little sand here, sand here, sand here, sand here. So essentially a longitudinal planet. If the forces of gravity are pulling this dust toward the middle and this dust toward the middle, at some point you're going to get around just out of random interaction. Every time a piece of dust falls, it is more likely to be headed toward the center. But once it's at the center, there's no reason to push it back out. And so even a stick would eventually transform into something round if the gravity force is strong enough toward the middle.
You know why that can't be? Let me tell you why. If you take the 4 Galilean moons that Jupiter has, Jupiter is essentially a sun that never ignited. It didn't have the mass to ignite, neither did Saturn. All these little gaseous planets, the big ones, they were stars that simply did not have enough mass. So what is the official version? The official version says, which is the Nebular Hypothesis, says that all these planets, these gaseous planets, simply condensed, from the matter that was around the sun. Okay, if that were true, which is essentially what I'm going to answer with respect to your question, the rocky moons of Jupiter, why are they at the same level as Jupiter, and why are they rocky? I mean, they should be gases as well. Why did they turn into rocks, whereas Jupiter turned into, a gas ball, which is what it is? See, all these planets, these gaseous planets, they have rocky moons, and these rocky moons are round, like Ganymede, Jupiter's biggest moon.
They're round above a certain size, because there is a lower size at which gravity is not strong enough, and then therefore they're not round.
Right, and that happens to some of the asteroids. But you take Ceres, which is the biggest asteroid, it's perfectly round. And the question, and you get some of these, for example, Mimas, the smallest object in the solar system, which is round. How do you explain that? You can't explain it just, this piece of rock that is so perfectly round. Did God, cut it into a little ball? No, it's a sun. It was a star once, billions and billions, trillions of years ago. Then you can explain not only roundness, but you can explain differentiation. On the other hand, if you're going to use the mechanism that you just explained, you're saying, well, you have this gas and other matter that's floating around, and it condenses, and then the heavier elements go to the center. Okay, that's what you were saying. Mm-hmm. Well, then we would not have next to Jupiter, we would not have rocky planets. Why are these completely rocky and this big guy here is just gas?
Quite easy. You don't have to invoke satellites to come from the same process as the planets. You can have satellites that have formed independently and that have then fell into the orbits of Jupiter.
Yeah, that's possible, but see, the way they explain it is not that way. They say that the way it happened is that you have collision here of iron and silicon and whatever, and here of gas. And they were at the same level. They were at the same distance from the sun, for example, right? The rocky moons of Jupiter, the rocky moons of Saturn, they were there. They were at the same level. And so the question is, how did this guy turn into a piece of gas, a ball of gas, and this other guy ended up being rocky? That's the problem. There is a big problem.
All right. It was them, Bill, always with his contradictory views with the mainstream science. When I talk with Bill, it's the only moment where I get to defend mainstream science. I get to be the non-contrarian. I love it. It was real in my mind says, we have proven that we alter photons by observing them within the double-slit experiment. This has the potential for binary communication. Yeah, I mean, whatever your interpretation of the double-slit experiment is, it does lead to quantum computing possibilities, right?
Well, I got obviously.
By the way, Bill, I never asked you about quantum computing. I hate quantum computers. Do you too?
Well, the problem is that they use the adjective quantum there, just to say that it follows, the uncertainty principle and decoherence and all this stuff that they invented in quantum. The point here is that they don't understand their own theories, but they use the word quantum simply to say as an adjective. When they say quantum computer, what are they saying? They're saying it follows the rules of quantum, which is that we don't understand it. That's what they're saying. In other words, they're not saying it's quantum because they've proven the theory, but they're using the adjective of quantum simply because they're saying, look, it follows all these weird things that we don't understand. That's why we call it quantum computer.
Yeah, that's the big problem of these things. It's that it will be non-logic in the end. Now, it may have specialized applications in quantum, in some form of password encoding, but I think for the vast majority of what we do with computers, we want answers that are repeatable and always the same. Coughing says there is almost an infinite number of ropes, but why there is no entanglements?
Aha, entanglement. People are always concerned with entanglement. The question they should ask before they ask about the rope entangled is whether quantum particles hit each other. You know, I mean, it's a billiard ball theory. You know, when light goes in this direction, the other one goes at 90 degrees. Do all these particles bounce off each other? See, they never asked that same question for quantum, and it's the same problem.
Well, good question. I mean, it's a problem. Intersecting rays of light. How does it happen? And can we actually neutralize a 90-degree ray of light using another 90-degree ray of light so that the waves cancel each other? Is there such a thing? Like sound cancellation, but for light?
If you ask Mr. Burke, who carried out experiments a few years ago, he says, yeah, it happens that light bounces off light. He does it with virtual particles. Anyone can do it with virtual particles because those are magical ones that mathematicians introduce at their leisure. No, light does not bounce off of light, and you can prove this to yourself very easily. In fact, there's two ways of proving it. The first one is you take light and run it through two magnets and see if the magnetic field of the magnet in any way deviates the beam of light. And relativity claims that gravity bends light. Okay, let's prove it. Let's see if we can do this. We take a laser in the desert, the longest distance you can imagine. Okay, in our flat Earth, it would be perfectly done. You point it from the one side of Antarctica to the other, right? Okay, so you got this laser, okay, and now and you pinpoint it. You measure it very carefully in where the pinpoint is, right? And now you put 1 billion trucks full of all kinds of garbage on one side of the beam. Well, it should bend the beam. It should take it away from that center point because you put all the trucks full of all kinds of things. You know, you put something very heavy on one side of the beam, it should bend the beam. And it doesn't. For sure it doesn't.
We've never measured on Earth a difference of speed of light with respect to the position of the ground versus the heavens.
The problem is you don't have enough distance to be able to really determine that. Remember, the moon, which is very far away, is about 1.5 light seconds. 1 second for light to reach the moon, so to speak, right? And that's very far away. So you can imagine you can't do that on Earth. But there is a way of, I got a little experiment for people to do if they have a little vacuum chamber. You take a beam of light, okay? You take a laser, for example, and you point it at a photomultiplier. Photomultiplier, what it does, it can measure intensity, among other things, right? It can measure the intensity of light. So you point it at the laser at the photomultiplier, okay? And now you pump the chamber down. Well, quantum predicts that if you remove matter from the chamber, the mean free path of the beam is now better. You should have a higher intensity. I swear by my mother's grave that you won't get a higher intensity. If anything, it stays the same or drops. Why? Because under the rope model, you're removing the atoms that are relaying the signal from the laser to the photomultiplier.
All right, so that's based on essentially you are saying if waves of light were photons, they would collide with the atoms otherwise present in the vacuum chamber.
Right. In other words, if you have atmospheric pressure, in other words, room pressure, right? And you put the laser and you send it inside the vacuum chamber, right? But at room pressure, and you send the beam to the photomultiplier, you get a certain intensity. If you pump the chamber down, like to the -7 or -8 torr or whatever, you remove matter from atoms from there. So now the beam the photons, they don't have anything to bounce against. Now you should have a higher intensity. I bet you any amount of money you won't get higher intensity.
But certain frequencies of light do get absorbed by matter. We see it because the sky is blue because of that. My understanding is that the air on the planet Earth, the atmosphere, absorbs some of the red light, and that's why the sky ends up blue. So there is some form of
Correct.
absorption, but it's at specific frequencies.
Okay, so now let's remove the air from the Earth all around. Should we get a higher intensity or lower intensity light in our faces?
Well, we should get a
get
little
higher
higher,
intensity, right?
and it might not be blue
Right.
anymore. Yeah.
Right. And so now let's do that in a vacuum chamber. That's the same experiment. We remove matter, we should have higher intensity. I'm telling you, you will not get a higher intensity.
I guess you just need a big enough vacuum chamber so that the relative sparsity of atoms in a gas can eventually matter. Because, I mean, we conceive of gases as being very poor in terms of density of electron and proton content, right? Well, atoms content.
Yeah, again, you know, if atoms absorb light, as we say, right, then if you remove the atoms that prevent light from reaching the photomultiplier, you should have a higher intensity. It's very simple. It's a very simple experiment to run.
All right. Alexandru Kohaniuk sends $10. Thank you so much. He says, Bill, in 100,000 years, you'll see the rings around Saturn forming a round satellite. Big rocks get rounder the bigger they are. Size correlates with roundness. I tend to agree with this.
Well, I don't. I'm saying that in order to get roundness and differentiation, okay, two things, roundness and differentiation, that means that you have layered, the ball is layered, okay? The heavier elements are in the center, followed by lighter elements, eventually by gases. You know, that's the structure of any star. And I'm saying all these planets, in fact, the moons, a lot of the moons, they don't have atmospheres, but they do have this heavy to light structure. And they're all the same. And so I think Mother Nature or Father Universe, whoever out there, they don't have such a sophisticated system. All they have is gravity. That's it. They work with gravity, and they can deal with gravity and make anything round and differentiated. And we certainly don't need the Nebular Hypothesis for every little solid object that's out there.
As a biologist, I've been working in labs with a centrifugal machine. We were putting mixes of matter in this that was coming, let's say, a whole animal, just or tissue coming from a plant or something. You put it in there, and the machine just turns around very fast. At some centrifugal force, you get differentiation in that the most heavy element will come to the bottom of your little tube and the lightest elements will stay at the top. And you can see actual layers developing. No matter what the weight of these molecules were, they will sort themselves out in terms of weight. Couldn't it be the same that explains the differentiation of layers in planets?
Again, the big problem there is that we have moons next to Jupiter, solid moons. And to say that all these moons came from abroad, that somehow they were thrown into Jupiter, well, that's not the Nebular Hypothesis. The Nebular Hypothesis is that all the objects here in the solar system were created by a cloud. And the question is, if that's the case, you cannot have a rocky moon like Ganymede or any of the Galilean moons next to a gaseous planet like Jupiter. That's going to be hard to explain.
All
and
right.
They never have.
Wonderful. Checkma6 sends $10. Thank you so much. He says, thoughts on dark matter. Well, we've talked about it in previous shows, I think, but you can give us a summary, Bill, of your position on dark matter.
Very simple, very, very simple. Under the general relativity version, it's simply dark matter is simply a variable in an equation. That's all it is. They've turned that value into something called dark matter. Nobody can see it. It's very heavy. You know, it's a spirit, a very fat spirit. That's what it is. Under the rope model, very simple. Think of a spider web that's rotating. So we have a rotating spider web. All stars are interconnected, physically interconnected. Every atom is connected to every atom, so every star is connected to every star. That's why stars don't fly out of the galaxy, and that's why the stars on the outside travel just as fast or faster than the ones on the inside, because it's a carousel. That's what a galaxy is. It's all tied together. So we have a physical interpretation. these people don't have a physical interpretation. They're looking for a ghost out there. They're saying there's mass out there. We can explain it with mass, but the explanation relies on a concept, on mass. How does mass pull on a star? That's what I want to know. And they don't have an explanation for that. They just say, we're looking for some matter out there that weighs a lot. That's it. And it gives job security to astronomers.
All right. Let's finish on one last subject, which was the claim of Owen Benjamin about nukes not existing. How do you convince yourself, Bill, that nuclear bombs exist? Do you believe in nuclear bombs? Do you believe they were detonated on Japan?
Yeah, I mean, all you got to do is go to Hiroshima and Nagasaki and ask those people there, if anyone are still around or their children or whatever. Did that ever happen? And I think they'll say, yeah, it did happen. In fact, it's very hard to believe that all these countries, India has the bomb, Pakistan has the bomb, North Korea has the bomb. All these countries have the bomb, and to say that all of them are lying.
On top of it, we have video. My understanding is there are videos out there of nuclear tests, right?
Well, those are made in Hollywood,
Oh, okay. All right, well, let's see the results of our survey of tonight. Is Owen Benjamin a nut job? 17 people answer yes, 4 people answer no. We have a majority concluding that he is divagating on these subjects. But what do you expect? He's a comedian. All right, Bill.
A joker.
A joker. And this launches me to the subject of the next show. So, dear audience, join me in the video that will just show up in maybe 10 minutes. I will be making the thumbnail and title. And let's start it tonight at 9 p.m. Eastern Time so that I get a 30 minutes break. I'm going to be giving my opinion on the Joker. Join me tonight on my channel. Bill Gaede, was there anything else you wanted to discuss before we conclude?
No. I think we covered a lot of subjects. The only thing I would say is that, people should look at the rope model if they want to get a physical interpretation. It doesn't mean that they're going to believe the rope. That's not the point. The point is, do you understand it? If you understand it, I've accomplished my goal. Absolutely.
I mean, I'm stunned by this model, despite my kind of instinct at wanting to reject stuff like this. It is very insightful on so many things that it would be surprising that it doesn't have any sort of value. I think it's very impressive. So go watch the Bill Gaede channel. It's on YouTube. The description is in the link below. Bill Gaede, I will see you again in the future. And to our audience, join me in 30 minutes on my channel. I will start an independent video. Let's talk about the Joker movie. Bye-bye.